Hello, all, and welcome to this live session here we are sending to all of you guys around the world. Please use the chat function and put in whatever questions you might have during this presentation, and we will attend to them as soon as possible. If not before, then at the end of this session. But to start with, maybe you can help us and put in the chat where you are from around the world, so we have an idea what kind of audience it is we are speaking to right now live. So please interact with us. Good. Let's get started. We have so much really cool stuff we want to share with you today. So I think we should jump right into it. And here on the first slide, let me just start by introducing who it is you will meet today. First, we have Einar Lukman. He's our technical manager within Danfoss Climate Solution. He is the daily technical responsible in our Smart Store and our Application Development Center. Today, you'll see a lot of videos we have done with him in the Smart Store, and they will be played throughout this meeting here today. Mark will be our main presenter. He will be the one who will, between the videos, give us much more details about what it is for kind of solution we have built here with our Smart Store. And I will be acting as a host for the meeting, so I will take good care of your questions and other interactions we will have with you guys. So please keep putting in, and I see a lot of you have already done so. I love it. So we both have colleagues from Turkey, sorry, not colleagues. We have guests from Dubai and Chile and Indonesia. So super exciting. Japan even. Very good. Exciting stuff. Good. Let's move ahead and get started. We have so much we would like to share with you because we are very excited and very proud, I can tell you, because here we are sharing with you the very first of its kind for us here in Danfoss. We have managed to build our Smart Store supermarket, so a real supermarket, the 365 Co-op, as you can see here on the screen, that is built together in the same building together with our very own application development center. As you can see on the picture here, it is all into one building, but we will show you much more about this very exciting project we have here, all integrated into one building. What we now have here on this screen is actually basically what we will go through today in this call. We will try to take you through a small journey where we focus on 3 energy streams. We will focus on what's going on in a cooling grid, in the heating grid, and the electric grid. So Mark will take this step by step and explain much more in detail, but all of this is what we will try to have all of this communication to be built around. But now you have a little bit of idea what you will get to see. So if you see any questions or have anything, could put it in the chat and we will get back to you afterwards. Good. I think that's it. I think we should just get started. Are you ready, Mark?
Yes, thank you, Anya. Good morning, good afternoon. Let's say I will stepwise walk you through system technologies, what we implemented on these systems, and I will start with the cooling grid. As you can notice, something which is a bit different than to the standard units, we have 2 packs. There is one standard pack and then we have advanced pack. Later on, I will explain you why we have 2 packs, because we would like to do benchmarking between the standard pack and advanced pack, and also to test also some differences in technologies. Then we have, of course, evaporators on the cabinets and in the cold room. Then we have a CO2 chiller. Why we have it? Because on the standard pack, we don't have implemented air conditioning load. So when we will run system with the standard pack, we will need to have a chiller. What is specific here? It is a CO2 chiller. Then we have a ground loop, what we are using in 2 functionalities. But when we're talking about cooling grid, we will use this also as a subcooling during the summertime. We have also possibility to store cold energy in tanks to be ready for the good start in the morning in the store. And yes, of course, we have air conditioning units. There are 2 units placed. One is for the supermarket area and another one is for the ADC. Now let's see in the next video what Einar did movie to introduce you to the store.
From the Danfoss ADC demo room, we have a view into the store itself, where we have 11 cabinets with medium temperature, and we have 9 cabinets with a low temp. All of this is controlled by Adapt Cool with AKC control, AKV valves, our pressure and temperature sensors, and monitored by the whole Danfoss monitoring system.
And how it looks looking from the top view. As you can see, it's a not a big store. It consists of course, cold rooms. One is low temperature, one is medium temperature cold room. Then we have low temperature cabinets, and then there are, let's say, 2 areas where we have medium temperature cabinets. What we also have implemented here are Danfoss gas detectors, which are connected to our system manager, where we are monitoring exactly what is the concentration of ppm CO2 in different areas. Of course, you need to have in each cold room, but also we are monitoring in the store, but also in some places where there is a possibility to have a leakage, and then of course you need to give alarm. This is for the security reason. Also, as a important to notice, we are measuring temperature in the store and also relative humidity. It's not just for the measurement, but also we are using this information to control real heat, depending on these informations to, of course, spend less energy if it's possible. Case controllers are from our quite famous range, AKCC55, single coil. In this case, we have 2 options. One is option without the display and the one with integrated display. Then on that controllers, both versions, you can connect different displays. One is without any buttons, one is with feature, what is quite nice. You can connect via Bluetooth to your application on iOS or Android, and then there is a third one where you have also Bluetooth, but also the setting buttons. This helps service technicians to get very good information what's happening locally in front of the unit, not to go to the system manager looking remotely what's happening. There is quite a nice overview and also some internal logging. Of course, we have a safety feature in our network unit to prevent that some unexpected entrance through the Bluetooth will enter to your controller and maybe do some things what are not supposed to do. So there are also preventing measures how to protect our system. Actually, this controller has not only one function, but it can cover 9 different applications depending on what configuration you have around your cabinet or in the cold room. It's driven by our famous AKVP valve. It's a pulse width modulation expansion valve. And then, as you can see here, we are monitoring pressure and temperature out of the evaporator, and using this information we are controlling how much we are injecting liquid to the evaporator to have as low as possible liquid out of it when we are running adaptive liquid control, which will be mentioned later on. We also possibility to have additional sensor to measure food in every area what you need. On our plant, we have 3 different configurations what we are using. We are using like a normal stand case with one evaporator, but also we are driving also some special cabinets where are driven by one single evaporator, but 2 areas. But of course, driven by only one electronic expansion valve. And then, of course, we have a cold rooms, what I've mentioned before. And now let's see what what is driving this beside cases and cold rooms. Let's see our packs, what Einar did recording.
Yes, just before the video, I just want to thank everybody for joining in and putting in all the places you are from in the world. By all means, if you have any questions, please make sure to put them in the chat and we will revisit them as soon as we can. So be very active, then we will be able to get back to you. Thank you.
Thank you too.
Here in the demo room, we have 2 refrigeration packs, a standard one in the back end and the advanced version we have up here. And with a lot of Danfoss equipment and controls, we have heat recovery. We have our high pressure valve, CCMT valves, also for bypass. We have our ejector technology. We have Danfoss box compressors. We have Danfoss drives. And we also have the control by means of the PC72 pack controllers, and with all the IOs as can be seen up here, taking control of the whole unit.
Okay, as Einar said, we have a standard pack. It's standard CO2 transcritical pack consisting of low temperature evaporators. In our case, we have a load of 13 kilowatts there, and then we have on medium temperature evaporators load from 29 kilowatts. Then we have low temperature compressors, medium temperature compressors. They are configured in a way in a booster mode. So LT compressors are discharging gas to the suction of empty compressors. Then we have a gas cooler, because with CO2 transcritical system, we are not calling this anymore a condenser, but a gas cooler, because we are going above a transcritical point. Then what we applied here is a heat recovery. This is the load what we have to manage in the store and also in this application development part of the building. If there is not enough load in the system, especially during winter time, when the load on evaporators are dropping, and then simply our compressors have to manage these low load conditions. But from other hand, we are requesting to have a high heat demand to supply to the building, because it's of course winter. Then we have a additional evaporator connected to the ground. It's on a level of 20 kilowatts, where we can actually get into kind of heat pump mode to create even more heat for the system, and of course delivering to the buildings. Then to control pressure in the gas cooler, we have a high pressure expansion valve, which is controlling pressure in the gas cooler depending on, first of all, ambient temperature measurement, and then from ambient temperature we are defining what is the reference temperature out of the gas cooler. From that we are calculating what should be the reference pressure in the gas cooler. So this is something which is specific for the CO2 systems. After this high pressure expansion valve, we need to control pressure in the receiver. Someone is calling also separator. And here we are controlling this pressure by using gas bypass valve. All in all, this is a standard CO2 transcritical system. What we have as a next to this standard unit, it's advanced CO2 energy pack. Beside all these units, what we discussed before, we have something what is additional. First of all, we have a control after the gas cooler with our modulating three-way valve, which is capable to tune this temperature out of the gas cooler in a very cold climate conditions, but also during a heat recovery process, we can completely bypass gas cooler and in that way we can even more create heating during the winter season. But what is additional also? We also have a technology, what we call ice melting. So after the gas cooler, you have a relatively colder CO2, but still we can use this to heat up the glycol water system. It's a hot water system to melt ice in front of the building. And also what we have is possibility, and this is technology what we are using in the summertime. It is this ground cooling, where we are using this ground as a heat sink, also to do additional subcooling to increase efficiency of the system even more. Then together with high pressure valve, we have in parallel combi ejector, which is actually part of our multi-ejector solution. And to know, we have different technologies, and here is implemented technology combining of high pressure lift ejector, which is mandatory to be used together with the parallel compressors. And in the same block, there is a liquid ejector, which because of the nature of this system mode operation, you need to have also a suction accumulator, which will capture liquid portion which will be released from the medium temperature evaporators, and then is bringing this gas and liquid through the ejector to our receiver. All in all, We also added to that system air conditioning load, where we are during summertime have to provide this called glycol for the air handling units, which is driven by our low pressure lift ejector, and it works in a way like a small internal compressor. So we are recovering energy from the high pressure to do some useful work in the system. PEG controllers, very briefly. One PEG controller have capabilities to control up to 10 medium temperature compressors, 8 parallel compressors, 4 LT compressors, and in each of these suction group we can apply 2 variable speed driven compressors, and as you can see here on the screen, there are all these drives implemented here. Of course, this controller is controlling pressure and temperature in the gas cooler, and also controlling the receiver pressure by using gas bypass valve. And when there is possibility to apply parallel compressors, and here we recently introduced very smart function where we have this smart switch between the gas bypass valve operation IT compressors. More of those things we will explain in some other sessions coming in October. Then this controller can also manage our different ejector systems coming from high pressure lift ejector, liquid ejector, which is implemented here, and low pressure lift ejector system. Of course, heat recovery is also one of the things quite important to have this all-in-one solution in one let's say system. And what you will see later on, it's not necessary to add any additional heat source. Multi-ejector solution, as you know, I mentioned there are different versions we have in our portfolio depending on different applications. Once again, in our case, we use this combi ejector, which is a combination of HP technology and liquid ejector technology, or to have, let's say, 2 systems in one. And then there is also implemented low pressure lift ejector for this air conditioning load. Of course, this is a relatively small system, but if you have a bigger systems, then we can combine with much bigger blocks to manage these requirements. What we are very proud to say that recently BOC team joined Danfoss, and we of course implemented those compressors on our systems, and our idea was to show all possible options for CO2 systems. So in the standard system, we apply transcritical CO2 compressors, which if you look at the range of those compressors, there are 4 housing sizes with 19 displacement stages. Then also on the subcritical, we implemented, let's say, standard compressors there, which are designed to withstand pressure on the suction side up to 40 bars. It's quite important to know when a CO2 system is without power supply because of some interruption, because of the heat getting into your system. Of course, the pressure in the systems will slowly go up, so you need to protect your system. On advanced system, we wish to have even more advanced compressors to show all possibilities what we have. And here we introduced compressors with, same compressors, but with LSPM motors, which has a much better efficiency than the normal asynchronous motor. And on the subcritical side, we implemented LT range of compressors, which are designed to withstand 100 bars on the suction side, which is again extremely important when you are getting into these standstill situations. There are these there are options for these 2 housing sizes with these pressures, but if you will need to have a bigger capacities, there is of course solution to use let's say, normal transcritical CO2 compressors, but with a special, let's say, a motor. And in this case, this is ML version. And then, of course, you will get to all the varieties of capacities you would like to apply. This is something what we wish to talk about refrigeration technology, but let's now look how we are adding to refrigeration technology or cooling grid heating grid. So first of all, our both packs have possibility to produce heat, which can be used, of course, for the heating, ventilation, air conditioning system. We can also store this heat in the tanks, which can be used also in both directions. It's used also for the hydronic balancing system, where you are different heat demands, like radiators or fan coils, also for the de-icing, what I mentioned, and also for the ground loop. We are using this heat sink to produce more heat when we need in this, let's say, heating application. Also, this system is connected to the external heating grid. In our case, it was a district heating. Let's now see how we are connecting refrigeration system to our unit, what we call a heat recovery unit. Let's look this in the next video.
And just before we start the video, Mark, I just want to thank everybody for being so active in the chat. I can see I have combined 100 messages, so I'm totally overwhelmed. So thank you for that. Now I have an idea for where you all are from, so that's good. Please make sure to put in whatever questions or thoughts you have, so we know what to pick up on topics going forward. So please put in whatever you have in mind in the chat, so we can act upon it. Thank you. And now it's time for the video.
Behind me, we have the Danfoss heat recovery unit, which is connected to the refrigeration packs, and we can recover all the excess heat from the systems. We can buy heat from the district heating if we need, and we can also sell back excess heat directly to the district heating system. It's controlled by a Danfoss ECL controller, and it's also monitored by the Danfoss heat meters. So.
Now I will try to explain you how the system works. So as Einar said, there is a heat recovery unit, in our case consisting of these two tanks, which are connected in a way, if you can imagine, like one very tall tank. It is important to have a really good temperature stratifications in these tanks, because in that way you are avoiding mixing of these cold and warm streams. It is controlled by the ECL controller with a dedicated application, and when there is a request for the more heat to be applied to those tanks, it's coming to our pack controller. Pack controller is controlling either a standard unit to produce more heat, or advanced unit to produce more heat. And then from one of those systems, you will have a heat recovered to your system. When you get this heat, of course, you have to provide this to the consumers, either air handling unit or fan coils or radiators. And in principle, our system is self-sufficient, and we are able to provide enough heat for the store itself, but also for this additional building what is next by. But what we also wished with this system to show additional features of what we have. It's an option. You can connect it to the external heat source. In our case, this is district heating, but also we have possibility to sell heat back to the, in this case, district heating. And of course, when we have a surplus in heat, for example, in summertime, there is no demand on our buildings, but still refrigeration system will work at the higher pressures because of higher ambient temperatures. We will definitely have a surplus in heat, and then we can resell this heat. This is one case. Another case is also, you will see we have possibility to do some, let's say, optimization of the system, and then look if we have a surplus in energy, what we are producing, to also generate more heat by using our pack units, and then deliver this to the district heating, and in that way reuse this energy in that way. But let's see how we are distributing this heat to the consumers first.
Heat generated from the heat recovery unit is then distributed to this heating system, where we are controlling mixing loop and the heating system by ECL. We have a mixing loop for the radiator system, and we have also the Danfoss floor heating system, as can be seen here. So all the heat generated by the packs is used in our own heating system.
Here you can see just two examples of how we are monitoring those controllers. On the left side, you see heat recovery unit, which is in this moment what we captured is charging heat in the tanks. There is not big demand for the consumers. There is no consumed energy from external source, because of course we have enough heat coming from our CO2 system. Of course, we are in this case for the moment we are not selling any heat. But then also in the let's say distribution area, this is one example of the mixing loop of the radiators. We are of course monitoring closely how to manage those systems. Let's look now how our air handling unit and chiller is managed.
For the Smart Store, we have two air handling units, one for the store itself, this one, and another one for the ADC area, which is outside. The hot water we're getting from the heat recovery unit, the cold water for cooling from the chiller and the advanced pack. And the air handling unit is controlled by a Danfoss ECL controller, and also the fans are controlled by Danfoss drives. The ECL is controlling the mixing loops for hot water and the cold water, as can be seen over here, also with ABQM valves. And outside here we have the chiller, which is based on a Danfoss condensing unit, IC2 condensing unit, and we have built a heat exchanger on top of it. So that's for the comfort cooling.
Yeah. So here on the scheme, you can see a chiller, what Einar just mentioned. Of course, intention is to produce cold water. We also have possibility to produce cold water with advanced CO2 energy pack. When advanced CO2 energy pack will be not in operation, but we will run with standard pack, then of course to produce cold water, this chiller, which is mounted on the roof, will be used for that purpose. How we are how we are utilizing this cold water, you can see here on this air handling unit. In this case, this one is for the moment in operation, and of course we are managing this temperature in the area. There is also a loop for the heating. There is a fan running. We have also a possibility to mix this return air and also to take fresh air. We also have a rotary wheel, which is in this particular moment not in operation, to have this energy recovery. And also we have exhaust fan, which will deliver this air out of the system. So these are technologies regarding heating and cooling, but let's see now regarding electrical grid, what we have. We have photovoltaic source, which are mounted on the roof of the store connection. We also have connection to the grid, and here with the talking about grid, we are talking about smart grid. Many features what we have today, but also what we are planning in the future, will be implemented to have a utilization of our system in the best way as possible. Of course, this energy is used for all this equipment around in the system. For the moment, there is not installed yet a battery storage. First of all, we would like to learn how much energy we are producing with our photovoltaics and how actually we can reuse immediately on the store. And then if we have a surplus to store this energy and then later on to reuse. So for the moment, we are analyzing how big batteries we will need in the future. But let's see how these energy streams are looking from the roof. Coming to next video.
What is important for this store is that we can optimize the energy streams. And behind me, we have 100 kilowatt of solar panels. As you also have seen before, we have the heat recovery unit where we can recover all the excess heat and sell back to the district heating system. So this is about optimizing the energy flows so we can have the lowest possible energy cost.
What is important to mention once again, our aim is to optimize energy cost. So in that way, we are looking how we can combine all these three energy levels and to reuse them in the best optimal way. We have possibility to store energy in the tanks. We have possibility to use ground source for heat pump operation or subcooling. We have possibility to resell heat or buy heat if, for example, price of energy from the district heating in this case is quite attractive. Maybe there is a sense also to use this heat from the district heating rather than produce from the PEX. Vice versa, if we have a situation that we have additional electricity what we are producing and the price wise it's better to produce heat using our PEX, of course we will produce it with our PEX. Regarding smart grid, regarding limitations, we can get a signal to limit compressor operation, just not to go over this limiting levels, and in that way we can avoid to have additional charge for having a more consumption than what we are claiming as a limit. And of course we have to adjust our system to work in that way. Of course, the second point is what is very important to maintain the temperature in the cabinets and in the cold rooms like it should. All this is monitored and managed by our network unit, AK System Manager 800, which you will see in the next video.
Here we have the System Manager 800, which is monitoring the whole refrigeration system and also the part of the heating system. We are controlling and monitoring the CC55, the pack controls, the PC782. We have MCX control, we have extra IOs, and as can be seen up on the screen here, we can see the different applications. We have the store layout, we have the standard pack, we have the advanced pack, we have the comfort cooling, and we have also the heat recovery unit. So all this monitored by the System Manager 800.
Yeah, to look on a simplified scheme, as you can see here, System Manager is communicating read and write possibilities, of course, to our evaporator controllers. We have Danfoss gas detectors connected to through the communication line to the System Manager and also pack controllers. So this is, let's say, standard refrigeration part of the system. What we have additional is here this air conditioning area where we are producing cold water, and heat recovery unit where we are producing heat. And as a glue between those three systems, we are using Danfoss open kind of PLC controllers where we develop our own application which is managing those systems, of course adapted to all this complexity what we introduced in this system, and managing when we are applying different technologies looking from the ground source, looking from the cooling loads, looking also for the heating loads. So it's something which very easily we can explain like a glue between all those systems, and of course connected to the system manager. To know what is happening in the system and how to compare those systems and technologies, we have plenty of energy meters installed all around, like main meters, then many sub meters of different technologies, so we can identify how much we are consuming on almost every line. What we can also do with the system manager, we can connect to our cloud solution, we call it AllSense, where data can be stored and analyzed in a also much more advanced way, and also data will be stored here in a much longer time than what we have as a storage facility on and memory on a system manager as itself. Besides screens, what you have seen from Einar in the video, there are possibilities. You can look directly in the system manager, all these history logs, what you define, you can define in the different sampling rates. Here is example of some temperatures and pressures, what we have here. Then you can go more deeply into the system view with kind of more graphical, informative way. Then you can also have a very easy way of looking at your evaporators to see a simple overview of the cooling conditions. And then as one of the interesting feature is also to have a HACCP reports where you can download those and have this for the inspection, what is necessary for the legislation to prove that your products were cooled in a decent way. This is all what we prepared for today, but let me now try to announce the new sessions which are coming in the next weeks. So we will start at the beginning of October, so 5th of October, with the first lesson where we will deep dive more into the standard system, standard critical refrigeration system, where we will explain some more features, what we didn't have time today. And then we will talk about heat recovery unit and hydronic system, balancing system, which is extremely important to get the best utilization of these two technologies. Also, part will be explained how we are driving CO2 system when we are in this heat recovery mode, because it's something which is a bit special in CO2 system comparing to all other systems, other refrigerants, what you know. After that, we will have a 12th October topic focusing on this advanced critical refrigeration system, where we will definitely talk about ejectors. We will talk about this air conditioning load, what we implemented there, and also these different technologies, what we applied there, and how we see the future of advanced system. Next to it, there will be a guest who will, from the BOC team, who will talk about more deeply into the BOC compressors to give you overview and why we believe BOC compressors are great compressors to be used in CO2 systems. Next, there will be 26th of October, focus on cabinets, evaporators. We will talk about specialties with the controller I mentioned at the beginning. Many options, what we have, what was not implemented here, but you can of course implement it here. There will be topic about gas detectors and also expansion valves, why we believe this is the perfect option for the supermarket application. Beginning of November, 2nd of November, we will talk about system manager and store view application, how you can access using your browser, and then to see and how to adjust the system and what network functions we use to optimize system, coming from the defrost schedules, coming to the real heat control, coming to the calm system, what I mentioned, coming to the day-night operation, etc. And also how we are thinking to do this management of these energies between these technologies. All in all, the last one, 9th of November, we will talk about Alsense cloud solution, where we will talk about this system developed to monitor not only one store, but multiple stores, hundreds or thousands of stores, and to make ease of understanding what is happening in your systems and how to focus on troubleshooting and to focus on those which are not performing right. And Anja,
Yes.
now you will explain us how colleagues will register for those sessions.
Yes, for sure I will. So we will be able to share a link with you very shortly, I believe, where you simply log in, you click the link, and then you simply just click which of these trainings you like to have. I suggest you simply take the one in the top where it says select all, because you should of course sign up to all of our trainings. Because if I may say so, this is exactly where you get a lot of very nice, more deep dive content. Because today is just a sneak peek, as you probably have seen, but I would really encourage you to sign up for all of these webinars that we will have here. They will also be recorded, so don't fear if you will miss out and not join. Don't worry, we will record them and we will share them publicly on our website. This way, this is not the first time we have done this, so if you cannot wait until the 5th of October, then I encourage you already now to go in and visit our website. We have simply a website that is focusing on CO2 in general in food retail, where we are having our focus. I hope my colleagues will share a link to it here in the chat in a sec, so you can have a link to go in there directly into our CO2 website, because there is actually quite awesome content, if I may say so. We have a really nice CO2 brochure that Mark and many of my colleagues have created, that way I have a really good overview. And as you can see down the red button at the bottom here on this website, is taking you to that one. Yes, so when you get the web link in here, you click there, and then you will be able to see the ONF24 trainings, and there is actually 9 of them that Mark have already performed, that is giving you really a good deep dive into all the different CO2 solutions that we have, that is made based on our mobile training unit, which is this training container that we have traveled the world with. And there's quite some nice videos that are deep diving both into ejectors, heat recovery unit, high pressure valves, and everything. So already now, if you cannot wait for 5th of October, go in there and visit them. And then I hope you'll be prepared with a lot of questions that you could share with us when you join our live sessions there, starting from 5th of October. So we have a lot of exciting content for you. So please all come, join, and we will look forward to have a really nice dialogue with you. And here, in the meantime, while you're presenting, Mark, you have no clue, but I can tell you, we got a lot of good questions.
Good.
Yes, and I am thinking we probably just have to jump right into it and say we would like to take some of the questions from the audience now. So we can see if we can answer them on the fly. And if we will not have time to go through all of the questions, then we of course will answer you after this call. We will then give you all a reply, because we have a lot of good questions coming our way. And let's see if I can, yes, we have the first question here on the screen, and I'll just read it out loud. In countries where temperatures are high, is it advisable to use the heat recovery unit? Do you want to take that, Mark?
Yes, in our case, we have possibility to get heat out to the refrigeration system and not to release this heat to the ambient. And we have possibility to sell this heat to the district heating. In our case, we have this option by selling heat, of course, I mean, we will earn some money at the end of the day selling this heat back to the district heating. And in many situations, this is also benefit for the district heating, because typically during summertime they are doing renovation of their systems, and actually they are looking for this kind of additional heat source during summertime. And in that way, it's a, let's say, positive situation for both of let's say companies. We as something which will produce heat and sell, and then also they can also rely on this and have, let's say, more space for their renovations, let's say.
Very good. Then I think we're ready for the next question. And I will try to read it out again loud, because some of our audience might see it on a very small screen, so maybe it's not easy for them to follow. So I will, as soon as we see it on the screen, I will read it out loud, and then I will see who of these two gentlemen will jump in and try to answer it. And while we're waiting, I can say, Einar, thank you very much for the videos. I think that was really a super good job of you there, making the videos so we could have a sneak peek and share with everybody here. So the next question is, can we estimate how much savings we can gain compared to a standard transcritical CO2 system? Who would like to take that one?
I can at least try.
Yes.
We have just had it running for 2 months now. So and we are in a startup phase. But compared to a first generation CO2 plant, at least the idea is that we are saving at least 50% compared to first generation CO2 system. But we are doing monitoring, as also explained by Mark, during the next year here. So we will have a fact-based calculation and presentation of the energy consumption with the different technologies. I saw a number of questions also around what is the payback time and does it make sense for different technologies. I think it's worth mentioning that our store is not a standard store. We have built a store where we can present the technologies available for supermarkets around the globe, from small stores up to bigger stores or hypermarkets, from cold climate to hot climate. That means that not all these technologies Mark have shown you make sense in one supermarket. It depends on where you are in the world. But we want to have the possibility to showcase the technologies available. And we are not cheating here, because all the technology we have shown you is something which is available for customers. So the idea is for us to showcase what we can do around the world for our global customers, and not all of it makes sense at the same time.
Yes, very good answer, Einar, I would say, for sure. Good. Let's take the next question. And here's a question that is about what target regions do we see and what kind of buildings is recommended for the heat recovery unit? And in general, when is it cost efficient to consider in doing design? Mark, you want to? Yeah, yes, Einar, by all means, take that.
For the supermarket chain, it's a private owned chain which is running the supermarket here in a franchising. But they have 12 different supermarkets, from a bigger supermarket to the smaller ones. And their calculation in Denmark, we have to say, is a payback time for the heat recovery unit between 3.7 and 3.8 years. And they have decided now to actually invest in heat recovery for every store they have. But again, as Mark was also mentioning, it depends on where you are in the globe and what kind of heat do you need, because we know in some countries you are not needing a lot of heat, especially not for heating the building. But it could be that you still need a lot of heat for hot tap water. And there it could also make sense that if you have a lot of heat or need in a certain, when you're starting up a store or you have a lot of cleaning to do, that you are utilizing a heat recovery unit. So it has to be calculated what kind of heat consumption you have at what temperatures. But at least I can tell you, if you're not recovering the excess heat, everything will be thrown out to the birds. And it's pretty easy to add a heat exchanger to a refrigeration system, a CO2 refrigeration system, to recover heat. I don't know if you have anything to add, Mark.
Yes, to add, you have seen here we used, let's say, the most advanced heat recovery unit with all these options, what we would like to test and show to the customers. There are also, of course, options where you only have a heat recovery from CO2 system and deliver this heat to the consumers. So it's quite simple solution. We are running a lot of systems in I would say in Europe for the moment, where there are no additional heat source. So all the heat is provided from the refrigeration system. So in that case, you don't need this connection to the additional heat source, and of course, selling heat. So I mean, there are so many options, of course, depending also on capacity wise. how much heat you need, how much heat you can produce from your refrigeration system. So there are many options. So don't look this as the only option what you have seen today, but also we will explain this in the first session what will come at the beginning of October, all these options what we have, and maybe you will find something which is suitable for your systems.
Yes, very good, Mark. Maybe just to note that the only thing that's really critical is that it needs to be a CO2 system you have, and you can always add this on. So even though you have a CO2 system running in your supermarket, you can always add this on the heat recovery unit. We're actually seeing that a lot of places that we simply build it on as a retrofit because it just requires that there's space, of course, and the heat exchanger, and then the heat recovery unit, and then you're actually able to add it on whenever you have time to do the opportunity to do the investment. Yes, we really expect a lot from this new opportunity with the heat recovery unit. Good. Then another question here, and that is a little bit more into the evaporator area.
Yeah.
Is there a reason why pulse width valves are used rather than stepper driven on evaporators?
I'm saying we are not having one or the other, because we have stepper valves for our chiller, and if you have a application like a chiller, it definitely makes sense to have a stepper valve if it's a very small amount of refrigerant compared to the capacity. For the cabinets, the food retail cabinets, or even the rooms you see in supermarket, the pulse width valve we are using, the AKV valves, is actually a combined solenoid valve and a valve in one. So it's a very simple way of also ensuring that you have a normally closed function when there is no power, or if someone is cleaning a cabinet. And this is at least something we see as a big plus for us. But perhaps you have more details to this one, Mark.
Yes, you said perfectly that when you have plate heat exchangers, absolutely stepper valve is a better option. But when you have these air-cooled evaporators, then it's pulse width modulation option really good solution, and especially in the systems where you have a multiple similar size evaporators, like in the supermarkets or distribution centers, etc. What I mean, and we have is it 30 years now, Einar, experience with those valves? I believe yes, more than 30 years.
First valve was introduced in 1987. So yes, absolutely.
So, thank you. So we have quite I mean, big experience with those valves and applications worldwide. What we did 5 years ago, we did upgrade of AKV valves. We implemented this soft opening and soft closing to reduce this noise which was present even more in CO2 systems, because the pressure difference is much higher than, let's say, in other synthetic driven refrigerant systems. And then we introduced this soft opening closing, which of course even more increased the way how the system is working and reliability of the system. So
what you call noise in the US, they call it the sound of money, because the saving they are creating by using an electrical valve here. So
Yes, good. I think we're ready for the next question. Good. Here is a question. With all technologies developed for CO2 systems, does the Smart Store simulate to operation in tropical countries like Southeast Asia region?
okay. One very typical application what is used in this warm climate area is this adiabatic gas cooler. Yes, we have also this option to be used in on our system. No matter what, in Denmark, maybe it's not big sense, but as Einar said, we would like to show, test, and present all technologies what can be used worldwide. In some areas, some technologies have sense, on others maybe not. So besides this gas cooler, which will this adiabatic cooling, which will decrease ambient temperature, which is cooling this gas cooler, this will of course increase of the efficiency of the system. The second is technology, these ejectors what we have. When you have a higher pressure in the gas cooler, you can utilize more and more this high pressure as energy to increase efficiency of your system. Someone will say in a tropical climate, CO2 system is not efficient. Yes, it's definitely lower efficiency than when you go to the medium or cold climate areas, but also other refrigerant systems they are not efficient in a warm condition. So you have to think about this, that warm climate simply is not helping refrigeration system to be very efficient. But maybe as a conclusion, we can build even in a very hot climate CO2 systems to be better or at least the same efficiency like other refrigerants today.
Very good. Super good point, Mark. And we will very much have more dialogues with you. So if you would like to learn more, reach out to the local Danfoss team, and we will explain you much more in detail what it is we can do for you in your region. Good. And while I remember it, there is another question coming up here, and that is AKSM 808 the latest system manager? And I believe I can answer yes to that, but I don't know if you want to comment any more on it, Mark.
Please, you
I know.
first.
I would just answer yes.
Yeah, but what is the question?
If it is the latest one.
Yeah,
Yes,
of course.
it is the newest one. It is the one we
Yes.
are using and selling the most right now. So by all means, yes. Good. Then I think I just want to note, I saw another question that I just want to mention while we're here is that I saw a question if where we have the stores located, and maybe I was not specific enough in my beginning. That's my bad. We have built this very nice smart store and application development center simply right next to our headquarter in Danfoss Nordborg. So it means that it is simply if you come by Denmark and you come and visit our headquarter, then you simply will be able to both visit our headquarter, our production and everything, and you will be able to come and see the application development center and smart store by yourself. So just to answer that question on the go. And now I see there's another question here, and that is, where is this smart store located? Yes, exactly. It is located in Nordborg, Denmark. And that was exactly my point. That I've course should have said that before. Now we have another question. And by how much do you need to extend your investment to attain a smart store like in the giving presentation? And what is the return of investment of implementing this system?
As also I mentioned earlier, we have put in a lot more technology than what makes sense in a small store. And here we, in the standard solution as we have, is typically what we see in a smart store. And that's also what we're using for benchmarking, because the standard solution is the one which is already specified by the supermarket chain, which is running the operation. But again, we do have the possibility in this small store here, where the system is scaled down to fit the capacity of our store. We can calculate also what would be the payback time on a certain investment, depending on the store size and depending on the region where you are. And so by having all the technologies in-house and testing them one by one, not in a lab, but in a real store, because all the noise you see in a real store, we also see here. Someone forget to close the doors and they're overstocking. All these things we experience here as well. So we are actually able to test it on a live supermarket, and again, then we can scale up. When does it make sense to use, like, let's say, an ejector technology? When does it not make sense? And there's some of the technology we're showing, it does not probably not from a business case point of view or return on investment point of view. It does not make sense to invest in these smaller stores, but in hypermarkets, there's a lot of the technology you would install. So again, it depends, but we need to be exact on in what region and what size of store or how much capacity do we need to build refrigeration for to be able to also to build it. The standard system, we are on par with this store with what they are paying in smaller stores, in COOP, in the supermarket chain in general. So we have not built something for the standard system which is more sophisticated than what they're already using.
Good, very good. Now I'm told time is actually up, so we have to stop. I can tell you, you guys, that you have received a lot of praises. Great presentation. Thank you, Mark, for the really good and thorough presentation, and really nice videos, Einar. So good job. And of course, all about the questions. Good job. Only one thing I want to say before we end, and that is now we have presented a little sneak peek of how it actually looks like in Nordborg, Denmark. Now I encourage all of you to consider, if you want to go there and see it for yourself, then reach out to your local Danfoss team and start the dialogue of what will be possible and so on and so forth. But if you want to know more, follow the links, and looking forward to see you online or in Smart Store.
And I'm here, so just come.
Yes, Heiner is there, so that's really good. Cool. Well, thank you all for joining. It has been a pleasure, and have a great day.
Thank you from my side also for listening us.